We're going to start this third video for 8.6 with a question. If a to the third equals a to the x, so this little equation right here, what then does the x have to equal in order for this to be true? So think about it, don't give up, no IDKs. I know a lot of you got this. X has to equal 3. Think about it. If a to the third equals a to the third, that's the only way that can be true, is if x also equals 3. Okay, so we're going to use that principle. That simple principle right there is that those exponents have to be equal. If your bases are the same, is called the power property of equality. So let's just go ahead and jump into an example of how this property works. So basically you want to try to get the same base. So you can see on the left we have a base of 4, but we don't have that over on the right. So you can do some calculations. You want to try to get the same base. So it turns out that 4 to the 5th power is the same as 1024. Now that we have that, we can literally just focus on the exponents because we learned from that property that these exponents have to be equal. So what you do is you actually pop them out of the problem. You don't have to worry about the base of 4 anymore. It's almost like the base of 4 canceled, but not quite. It's not exactly what's going on there, but if it helps you to think of it that way, you can. You solve for x by adding 1 to both sides, and you can see that we get x equals 6. Now remember, we learned right here that it was 4 to the 5th. If I substitute 6 minus 1, you see that you get 4 to the 5th again. So it does work out. Don't get too worried yet. Let's go ahead and look at some examples, and I think it will become clearer to you. All right, so let's take a look at example 10. We're going to start with this 3 raised to the 3x plus 1. Just rewrite down that side. This 81, we want to transform it so that it's 3, but we need to figure out what exponent would make this 3. So basically, here's what I'm asking you, is what exponent, if I have a base of 3, would equal 81? That's what I'm asking you. Okay, you don't have to write down that part. Just want you to think about it that way. So there's a couple ways you can do this. First way is this. Turn your paper over. On the front side, at the very first video, we talked about this, and we can see when 3 is raised to the 4th power, it equals 81. So the exponent we're looking for is 4. Now hopefully you're thinking to yourself, hey, wait a minute, I'm not always going to have this table handy, so isn't there another way I could do this? Yes, this is where I need you to grab a calculator. So I'm using the same calculator we use in class, and what I would probably do is just go through different numbers till I could figure out what exponent I'm looking for. So I'm looking for an equivalent to 81. Well, I know I'm not going to do 3 squared because I know that's 9. So let's do 3 to the power of 3. And nope, that's 27. And then the next one I would try is 3 to the power of 4. And that gave me my 81. So I know 3 to the power of 4 is what I'm looking for. So what we're going to do is erase this box because I now know what goes in the box. And I'm going to put a 4 there. Now I can use that power property of equality. That's right here. And I no longer need the bases. You can even just cross out those 3's. It's not really what's going on, but it's okay for what we're doing. And now we're going to solve for x. So we know how to solve for x. We're going to subtract 1 from both sides. And I get 3x equals 3, so x has to equal 1. Bam, bam, bam. Done. That's how we do it. You can even check. 3 times 1 is 3, plus 1 is 4. We know 3 to the 4th is 81. Everything worked out. All right, I'm going to hold off on 11 because 11 is actually trickier than it looks. So let's go ahead and go to number 2 and 12 instead. I don't know why I put 11 there. All right, let's go to number 12 because it is a lot easier. So same thing. I've got this 9 here. I've got 6,561. So basically what I need to figure out is if I have a base of 9, what exponent am I looking for? So let's grab our calculators. All right. That was a pretty big number, so I'm not going to do like 9 squared because that's only 81. So 9 to the third. Let's try 9 to the third. I think that's still going to be too small. So 9 raised to the fourth. All right, and there it is. So it's 9 raised to the fourth power. That was the number we were looking for, 6,561. So we need a 4. Back on our paper, we're going to write a 4 here. So once again, we can ignore these bases and just focus on the equivalent exponents. 3x plus 3 equals 4. Subtract that 3 from both sides. Okay. I've got 3x equals 1. If I divide by 3, I am going to get a 1/3. Be really careful. That's a common error students might write. You might just write a 3 instead of a 1/3. But it will work. It will give us the right answer. All right, let's look at a couple more examples and then we'll wrap this up. For time's sake, I'm actually like you guys to work on 13 on your own. That one's pretty easy. I think you'll be able to see that one right away. Let's do 14 together and then we'll talk about what to do for a problem like 11. All right, 14, we've got 13, 3x minus 8, leave that the same. We want to use the base of 13. What power is going to give me 28,561? Jump to your calculator. You can see I still have the 9s in there from before. I'm pretty sure 13 squared is not it, but I'm going to put it in just in case. Yeah, way too small. So let's try 13 raised to, I'm going to jump to the 4th. Oh, and there it is again. So it's a 4 again. Trust me, it will not always be a 4. Okay, so it is 13 to the 4th. That's what I'm looking for. So I'm going to erase that box. You can leave the box if you really want to. And I'm going to put in a 4 there. Remember the bases, I can ignore them. Just focus on the exponents now. And let's solve. So add 8 to both sides. I've got 3x. Sorry, let me get the right color here. All right, 3x equals 12. So x has to equal 4. Bam, 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 bam. X equals 4. All right, quickly, but probably not quick enough. Number 11. Here's the problem with number 11 is there's no power of 4. There's nothing, okay, there's no power of 4 that would equal 32. So, yeah, there's just, because you got 4 squared is 16, 4 to the third is 64, and it's right in the middle. So it's not going to work. So there's a couple different ways you can do this, but here's the way I like to do this. Here's how I think about this, is that it turns out that 2 to the 5th power equals 32. So what I'd like to do for this problem, instead of working with this root base of 4, trust me, this is an advanced problem. Not all of you will need to get there. If you've got a base of 4, if I change that to a base of 2, well, 2 squared, okay, would give me that same base. I'm going to take that square and multiply it to the x minus 3 that already exists there. I've got 32. So on this left side, I'm going to distribute that 2, so I get 2x minus 6 equals, and I just told you that 2 to the 5th is 32. So I'm going to change this to 2 to the 5th. So what happened on this one is we had to change the base on both sides. This is an advanced problem. Some of you may never get here. This is really more of a challenge problem. We'll cancel those bases out, so just focus on the exponents. 2x minus 6 equals 5, and we're going to start to solve here. So add the 6 to both sides. Oh, and then I'm going to, oh, that was really nice. Now I'm also going to give myself a fraction. Some of you may be going, well, where are you getting a fraction from? I don't see a fraction. You're about to. All right, we're going to divide both sides by 2, and since 2 does not go into 11 equally, you have two choices. You can change that to a decimal, or I'm just going to be lazy. I'm just going to leave that as 11 over 2. Perfectly good answer. That is actually our answer. That was a really tough one for our second example. All right. Do not panic about that last problem. Sorry this video went a little bit long. Let me know if you have any questions, and go ahead and try 13 on your own.